Welcome to this special edition of Packet Pushers at KubeCon. For the good folks out there, why don't you tell me who you are and what you do?
Hey, I'm happy to be here. I'm Sachin Vasudeva. I run the product team at Zadida.
Okay.
Yeah, and I care about AI, I care about edge compute, I care about orchestrating workloads at the edge and helping our customers deploy in constrained environments.
That is a perfect segue into my first question, which is, I'd love to hear an example, a real world example of how you've implemented AI in an existing workflow to make it better.
Yeah. So there are several ways that AI is playing a role. So the most important path is our customers. Let's talk about the use case. Our customers are using Vision as an AI application where they're deploying it on a drilling operation,
Okay.
right close to where the oil drilling is happening, or maybe it's on a drill rig, and they're looking for safety, worker safety. So they're using Vision AI to get an understanding of who's wearing a hard hat, who's in a red zone,
Oh, okay.
and that AI is being hosted on a gateway, and it's making its way and alerting either local users that are there or even somebody who's back home and saying, maybe something came off the rig, maybe something happened, maybe there's a potential hazard in the future. So let's deploy that AI application at the edge and get these instant alerts either locally or send data back. And
Sure.
so we enable that use case by deploying this AI app as a workload on an edge compute that we host and manage. And we make sure that if connectivity goes away suddenly, the app continues to run and operate and provides continued local support.
So you're using AI or the oil company. I know that being on a rig is a very dangerous job. So enhancing the level of safety by using Vision AI to flag potential issues or folks who are maybe not following the safety guidelines and nudging them like, hey, you're doing something a little risky.
Yes.
I know you're tired, but you got to put the hard hat on.
Yes.
That's
one very common use case. Another use case is how are we enhancing the product experience itself with AI,
Okay.
which is all about an operational natural language experience where if you're deploying a workload via Kubernetes and you want to understand if my hardware has some challenges or if my runtime environment has challenges or if my actual app got deployed, right? You can actually ask our product an interactive question and it'll tell you versus looking at a dashboard. And that's a more recent development, right? Where we can bring it as a natural language integration with Gen AI, and now you enhance the experience itself. And now you can hook that up with other agents. So we can connect to the customer's agents that might be doing the same things. And we can help that orchestrate across a set of edge deployments, and then agent-to-agent establishment can happen. And that's the path we are on in terms of the forward-looking area. So that's a very different use case.
Yeah.
Now that one was edge AI, the second is AI in the product.
In the product, right?
Yes.
So in either of those scenarios, I'm curious what major roadblocks you've encountered that have, made it more difficult to implement the solutions.
On the edge AI side, the biggest challenges are around first understanding the edge needs.
Okay.
It starts with no assumptions being made on connectivity.
Right. The oil rig example, it's not going to have an Ethernet cable running back to a data center.
Right. It might be satellite connected, might be Wi-Fi connected, and that connection may go down temporarily, maybe even permanently. Maybe the node has to be shipped somewhere else at some point. So we have to operate in a way that we can be eventually consistent. And with AI, we have to make sure that there's less and less dependency on certain back-end systems to do that, right? That's sort of one example. The other challenge is the hardware itself. The diversity of the hardware is bringing, is a lot, right? I mean, we are talking about edge hardware starting with standard compute like Intel-based servers or gateways, but now moving into NVIDIA low-cost Jetson hardware, or even like purpose-built TPU, NPUs from Qualcomm.
Right.
All of these bring their own flavor of SDKs and supportability and integration with AI, because they bring their own inference engines, they bring their own challenges. So now your AI model has to adapt to that kind of hardware upfront from a deployment point of view. You might have trained your AI model in a centralized cloud, but the deployment is about the inference engine that you're tied to.
Right.
And that can have an impact on your performance.
For sure.
And you may have to retrain your AI model again based on the actual hardware. So that's
Wow. That seems like an opportunity from the hardware standpoint to have some open standards that all of them adhere to make portability a little easier. Though, what would the motivation for the hardware vendors to be to make it more portable, right?
You're absolutely right, spot on, right? There's a desire from the practitioners who are deploying AI to have the standardized formatting, the standardized model, engines, and inferencing, right? Because training, when it comes to AI, training is always centralized.
Right.
When it comes to inferencing, it's always at the edge.
Distributed.
It's always distributed. So now there is not a standard today. NVIDIA brings its own set of capabilities, starting from the inference engine to all the way to the catalogs of AI models, right? And it sort of falls on the customer and the practitioner deploying it, which is hard because the revision is happening very fast.
Right.
If you're launching more hardware to sell more hardware, you're also updating that hardware, you're updating libraries. Every 3 months, you might be updating something that doesn't work and it's not backward compatible. So yes, so there's a challenge. We recognize the challenge, or customers recognize the challenge. The good news is that you don't need a full-on abstraction model here. You just need to identify the ecosystem you want to play with and focus on that. That's how everybody's been dealing with it.
Reminds me a lot of the server wars back in the day when there wasn't as much standardization, and making a move from one major vendor to another was extremely painful.
Yes.
And then we started implementing some standards across the board that did make it, if not easy,
It's not easy.
it's still doable.
And we see the same challenges, say for observability of AI, right? I mean, Dell and the others now have this BMC where they bring Redfish as an open standard for monitoring,
Right.
right? That's an open standard. Let's take that same standard and deploy it on the edge too. Yeah. And bring it on the edge hardware. But now it's not on a Dell server with Intel GPUs or Intel or CPUs. It's really on a very sophisticated NPU. So you've got to figure out that piece. So yeah.
I was going to ask you what you would fix if you could wave a magic wand, but I think I know. I think it's going to be the hardware and making it more consistent with an open standard.
I would definitely start there. I think the other place is also looking at the inference engines themselves.
Okay.
So we can actually simplify that. What we need to do is AI is prevalent and it's going to become even more prevalent at the edge. And the idea is that you can decouple the model from the business logic.
Okay.
So today what happens is if you go talk to an AI vendor for deploying applications, they bring you an entire fully realized application. And the model is ingrained into the business logic.
Okay.
All the pre-processing of the frames, the post-processing logic, all of that combines into multiple containers into one single Docker image. But the idea is decouple all that because you cannot quickly, rapidly change your model. You cannot do A/B testing suddenly.
Right.
So decouple your model from your logic and then bring it later as a packaging exercise and then deploy it. And that's a better way of doing it. And then yes, if you've already identified the hardware and hardware is not a problem, then let's focus on the model rev being the next challenge.
Gotcha.
And that's what we think we need to do.
That's what we need to do.
Yeah.
Last question.
Okay.
What keeps you up at night? What in the world, in the sphere of technology, wakes you up or gets you worried?
I sleep really well at night.
Well, that's good.
And that's the key because the world around us is changing so fast.
It is, yeah.
And I think it's a race to keep up. So we have to step back and talk about where to focus, which problems to solve, and pick a tool in the time we're in. So today, MCP works great as a tool we can future proof, all right, we can use that. If we missed that a year ago, it's fine. We'll catch up again, right? Because what we're realizing is that it's the ability to be fast enough, the ability to be agile,
Right.
and then we can keep up. So
Kind of, you got to ride the current
Yes.
instead of fighting against it.
yes,
I love that. Well, Sachin, thank you so much for being a guest today.
already. Hey, it was my pleasure.